Hi guys, welcome back to our Maths Live group tutorial sessions. So nice to see lots of you here already. While we wait for some more people to join us, just to say that if this is your first time, hello, hi, my name is Frederica. I work at my tutor, and this session will be going on for will last for an hour today. And how we run our sessions, if you're new, is we'll do 45 minutes where the tutor will teach the lesson content, and then 15 minutes at the end for the majority of questions. But if you do have questions as the session is going on, then please do feel free to send them through. You can do this either using the chat or using the Q&A, and either myself or the tutor will make sure that we pick them up and get back to you. Also, just to say that all of our sessions are recorded, so do make sure that you have signed up to the online school where you can get all of the links to the recordings as well. And yeah, I think we're a good number to get started, so I'm just going to hand over to Molly, who's going to lead the session. Molly is, if you're new, Molly is our lovely maths tutor that we have, who is a student at Bath University and has done lots and lots of lessons with my tutor. And she's also been leading all of these live sessions. So if you're not new, then it's a familiar face for you. But handing over to Molly now.
Cool. Hi guys, I'm Molly, and I will be leading the session today. As it said on there, we're going to be doing like an algebra roundup because that's kind of what we've been looking at this week. And essentially what I'm going to do is I'm just going to spend a few minutes now just kind of telling you essentially what we've done, just reminding you of what we've done this week. And then I'm going to I've got loads and loads of past paper questions ready, some quite tricky ones that we're just going to work through together, and I'll kind of slowly go through the solutions to them. And just shout in the chat maybe if there's a specific topic that you want to do that we've done this week. I should be able to find them. So just quickly, what we've done this week. Don't worry if you haven't been to them all. Hopefully you'll understand through me going through these questions. It's just in case I mention things briefly that we've gone over this week. So we've done solving equations. So that was in terms of forming the equations as well as solving them. So sometimes with word problems, you have to work out what the equation is yourself before you actually even start to solve it. We've done formulae and expressions. So hopefully those will be familiar when we go through them. So formulae are things like Pythagoras theorem, where you plug things in and get a solution out. And expressions are just ways of representing information. Basically equations without the equals. So just one half of it, a way of representing something. Then we looked at a bit of proportion. So if you remember y being directly proportional to x, we did y equals kx. It's just that magic equals k, which makes these questions solvable. Then we looked at inequality. So we did, first of all, just some linear inequalities, and remember that they behave almost exactly like an equation. We can add things to both sides, multiply both sides by something, but if we multiply or divide by a negative number, we flip the sign. That's the key thing to remember about that. And then we did quadratic inequalities as well, where we worked out our critical values and sketched them on a graph. And then finally, yesterday, we looked at simultaneous equations. So we looked at the method of forming the equations. So in the case of word problems, working out what our equations should actually be. We looked at some really tricky ones with fractions, and we also looked at some quadratics where you need to use substitution. So hopefully that's all familiar. If not, hopefully it will make sense as we go through. So I'm just going to jump straight into some past paper questions that I have. So let's have a look. Go back up to the top of this, and we're going to start with this one that's on here, which is on direct proportion. So this is a basic exam style question, It's not too wordy. It's kind of what we looked at a lot when we did proportion. So D is directly proportional to X. So the first thing that we're going to write down is exactly what that says. D is directly proportional to X. Now, if you weren't here, you might be confused by this what I call fish, D squiggly fish X. And all this means is proportional to. Don't worry too much about directly proportional. The difference is directly proportional means that it goes through the origin. So I suppose this does mean directly proportional. Basically, we'll have a look at some graphs, but this is directly proportional to X. This is just proportional because it's proportional but shifted a bit. But don't worry too much about that. So we write down this, and then you might remember that we can replace squiggly fish with our equals K, because it basically means that D is some multiple of whatever X is. So D equals KX. This would, oh, that's a good question actually. I think that this is a calculator paper. I'm pretty sure. I'll be doing things without a calculator where I can, mostly because I'll have to use my phone calculator, but I'll let you know if you need to use your calculator for it. And then if we remember that this sentence, we just use all that sentence is there for to help us work out what K is. So we're going to do 36 equals 5K, just putting in X is 5. So then K is going to be 36 over 5. Now I'm actually just going to leave it as 36 over 5. I've said it a lot throughout the things. I much prefer fractions to decimals because it means that they're a lot easier to work with, especially if this was a non-calculator paper. Now that we've got K, we can rewrite this. So I'd always kind of either put this in brackets or something so that you remember the only reason you did that was to find K. And now we can write our equation as D equals 36 over 5x. We're just popping K in here. And now look at the actual bit of the question here, which says work out the value of D when X equals 8. And now it's just become kind of a formula question. Well, D when X equals 8 just means putting X equals 8 into this equation. So instead of times X, we write times 8. And then I'd say this is most likely now looking like a calculator question. I'm not going to bother doing like column multiplication or anything. I'm just going to do it on my calculator. So we will get divided by 5 equals, and I'm going to write this as a decimal just because that's what I've been given on my calculator, 57.6, which a lot of you got as the solution straight away. So that's good work. Hopefully that makes sense to everybody. Someone said, where do I get K from? It's really difficult because what I've kind of done is just like introduced K. This could be any letter, by the way. K is not special. K is just the convention used for a constant. Well, a constant in this case anyway. We're basically just putting it in there to work out what multiple it is. It's really difficult to explain, but hopefully if you do enough questions, and we'll think about it in terms of a graph a bit later on in the session, and hopefully that will make it start to make sense. We are actually going to do another proportion question, this time on inverse proportion. So I went over this very briefly at the end of Wednesday's session and talked a bit about how it actually differed from proportion. Oh, 2 people asked what we would do if we were finding D. Okay, a couple of questions, right. Sorry, I'll just go back to this and answer some questions on it. Someone said, what would we do if we were finding D? You just do exactly the same thing and you substitute it in. It would just take a little bit of rearranging. So I'll write an example here in grey for you. Let's say it was find D when X is 2. That would just mean, oh, sorry, finding, I guess you mean finding X. Let's say it was find X when D is 2. Then you do 2 equals 36 over 5x. And then to find X, you would do 2 divided by 36 over 5 and pop that into your calculator instead. So it's just substituting in a different letter and rearranging differently. Someone else said, won't the examiners get confused if you throw in a random letter? No, The examiners, this is the method. The examiners know what you're doing, I promise. If you put d equals kx, even if you put d equals fx, d equals zx, they know what you're doing. They know that you're just trying to find that constant of proportionality. Horrible long word, it just means this, what we've called k, what we multiply x by to get our d. Okay, we'll have a go at this now. If you've got any more questions, I'll come back to them at the end. Hopefully this will clear them up anyway, because this is a similar style of question. So D is inversely proportional to C. Now this seems a bit scarier, but it's totally not. All we're going to do is write D is inversely proportional to C is the same thing as saying that D is proportional to 1 over C, the inverse of C. Don't worry about understanding why that is, because there's not really a why, that's just how we define it, that's what it is. So just remember that inversely proportional means it's proportional to 1 over C. And now, this is exactly the same question. We replace our squiggly fish with equals k. So D equals k lots of 1 over C. K lots of that. And if we do k times 1 over C, because when we times a fraction by a number, we just times the top, this becomes D equals k over C. We don't have to write it like that, but it makes our calculations quite a bit easier. Hopefully you can see where that comes from. And now we're going to do the same thing. We're going to look, this second bit here is just telling us, here's what you need to find k. That's all that's doing. So now, sorry, this looks a lot like a 0. I'm just going to change this. Let's see. So now we're just going to use these values. So when C equals 280, D equals 25. And now we've got an equation with just k as the unknown. So we can rearrange. And the way that we're going to rearrange to get k, well, it's by multiplying up by 280. So we do 280 times 25. These are normally calculator paper questions. So that's 7,000. So our k here is 7,000. And then again, I'm going to kind of bracket this. Oh, my connection go? I don't think it is. Weird, okay. Bracket this. Why is the pen not working? I'm just going to refresh this page on here. Sorry, guys. I don't know what happened there with that. That's helpful, isn't it? I'll put the question back on and just put what k is. Sorry if you were writing that down. I don't know what happened. So we've worked out that k equals 7,000. So we know that our equation was D equals 7,000 over C. That's what we were doing there before the page crashed. It's just saying that we're just popping k back into our equation. And then what we want to do here is find out the value of D when C equals 350. So we say D equals 7,000 divided by 350. That's just where we see C, we write 350. And therefore, we pop that into our calculator. We see, I think it's 7,000 divided by 350 equals 20. So there you go. And a few of you got that as well, which is really, really good. So hopefully those questions make sense. Someone said they're still confused about how to find k. I'll come back to it at the end. I want to get through a range of questions at the moment. Cool. Let's have a look at another one. I'm going to do this one actually, which is quite hard to see. I'll pop it on so that we can write it. Because this is useful maybe if you work more graphically for understanding that element of it. So what we've got is 4 different proportionality relationships. So in each of these cases, y is proportional to something in terms of x. And it's one of these, it's either, so we've got to match them. Sorry, this is really small. Hopefully you can see it enough. So either y is directly proportional to x, y is inversely proportional, y is proportional to the square of x, and y is inversely proportional to the square of x. So I'll go through them one at a time and explain what I mean. And there's a really neat way to think about this. So let's think about this first one. Y is directly proportional to x. Well, let's think about what that means. It means that y equals kx. Now, which one of these looks like a graph of y equals kx? Well, it's this one, a straight line graph. We don't know what the gradient is. That doesn't matter. The gradient is our k that we're finding. But here, y is directly proportional to x. And that's what that means, is that you can draw a straight line graph between them. So the answer to this one is D. Hopefully that makes sense. You've basically just got to think about what it is that you're looking at. Let's have a look at this one. Y is inversely proportional to x. Again, let's just think about what that means. Remember, that means it's proportional to 1 over x. And that means y equals k lots of 1 over x. That little dot that I did, that just means times. So this is the same as y equals k over x. So this is going to look like some sort of 1 over x graph. Now, you might not have seen this before, but this is one that you just have to learn. Looks like this. So this is an inverse graph. This is a y equals 1 over x graph. It doesn't matter what k is. K will just stretch it one way or another, but it will look the same. Without a scale, it looks the same. So this one's going to be A. And some people are getting these answers already, which is really great. Let's have a look at this one. Y is proportional to the square of x. So that means y is proportional to x squared. That's how we write this one, which means that y equals kx squared. Hopefully you're getting the hang of this now, and you can see, well, this is just some multiple of an x squared graph. And we know that our x squared is a smiley face. So we know it must be this one here. Again, it doesn't matter what the k is. The k will just stretch it in some way. But without a scale, that doesn't matter. It's the shape that we're looking at. So this one is going to be graph B. And then finally, I mean, by process of elimination, we know that this one's going to be C. But let's have a quick think about y. Also, it doesn't matter if you don't understand y for this one. If you could do it by process of elimination, that is good enough. Kind of sneaky exam tricks. So y is inversely proportional to the square of x. So that means it's proportional to 1 over x squared. Inversely proportional, so 1 over to the square of x. Hopefully that makes sense how I got that. Which means that this is y equals k lots of 1 over x squared. And again, we can kind of ignore the k because the k is just the scaling. So we want to know which one of these graphs looks like a 1 over x squared. Now, the way that I would think about this here is that it's kind of like a 1 over x, but because x squared can only ever be positive, right? If you square minus 4, you get 16, positive 16. Whatever you square, you get a positive number. So that means that it's like this one, but anywhere where x was negative, a negative x did give a negative y value, well, that can't happen with an x squared, so we flipped it up. And that gives us this curve here. So that's the way to think about it. Or you can just learn that that's a 1 over x squared graph. So hopefully that makes sense, and it might make proportionality make a bit more sense. If people don't understand graph A, that's just one that you kind of have to know. If you're in a younger year or maybe haven't seen it, you might not have seen it yet, but this is just, you would just know that this is a y equals 1 over x. Just like you know that this is y equals x squared, it's another one that you kind of have to learn. No, you wouldn't have to show your working for these. So questions like these are always good to guess on if you don't know. So hopefully that makes a bit more sense. Cool, we'll move on from proportionality now. And we're going to have a look at some other questions. Here's quite a typical algebra exam question. One like this. So this says, simplify fully 3 minus x over 3x squared minus 5x minus 12. So at first sight, this doesn't really look like we can simplify this at all. Like, what can we cancel? What can we do to this? Does anybody have any ideas about what we could do for this question? Okay, yeah, there's some different ideas. Okay, there's some different ideas happening. So I'll go through some that kind of won't work, first of all. So several people said something to do with either cancelling out 3's or x's. That's a really good idea. That's a good kind of thought process to have. But unfortunately, when we divide a fraction by something, we have to divide every element by it. So if we were to cancel out the 3's, this would become 1, but this would become x over 3. And this would become x squared, but this would be 5x over 3. So if this and this were divisible by 3, it would be great, and we could do that. But unfortunately not. Same with the x's. People had really good ideas about cancelling out the x's somehow. But because with fractions, you have to think about it in terms of elements. And by an element, I mean something added or subtracted from something else. So unfortunately, we could do it, but it wouldn't help us too much. But what a lot of people said, which is quite right, is that we're going to factorise the denominator. Because if we factorise the denominator, then hopefully one of the factors will be 3 minus x, and we'll be able to cancel something out. So let's go ahead and do that. Now, a lot of the time when you're doing papers, they're written in a way to try to help you. So for example, we're not just going to straight up try to factorise this. We know that if they want us to simplify it, one of the factors must be 3 minus x. Well, 3 minus x is the same as, let me write this out. Don't worry if you're not following this, it should make sense at the end. But 3 minus x is the same as the negative version of like x minus 3. And that's because this is minus x, positive 3. And the reason that this is nicer is because x minus 3 is a more comfortable factor for us to find of this. So basically, because we know it cancels with the top, we know that one of the factors is going to have to be x minus 3. And that means that we can work out the rest of the equation, which is nice. So if we have a look at this denominator here, 3x squared minus 5x minus 12. Well, if one of the factors is x minus 3, we'll forget about the negative for now. One of the factors is x minus 3. Well, what's the other one going to have to be? Well, in order to make a 3x squared, the first part of it is going to have to be 3x. And in order for this to make 12, this bit, minus 12, sorry, this bit's going to have to be a positive 4. So let's just check that that works with our 5x. We're going to get plus 4x minus 9x. And yeah, that makes minus 5. So we've managed to factorise that with no real effort put in, because we've got into the examiner's head and realised that if they want us to simplify it, x minus 3 has got to be a factor. So you can often do some sneaky tricks like that. Some people are saying, how do I get x minus 3 again? It's because I basically swapped these around and put a minus sign. If we just think about expanding this out, we get a minus x here and a minus 3x, so a plus 3. So we get the same as this, minus x and a plus 3 minus x. And the reason that I did that is because I wouldn't want to factorize this with a 3 minus x, you know? So if you ever see it like this, flip it round so that the x is in front and put a minus at the beginning. So now we can take this, and here's what we're going to set it equal to. We're going to write the top as exactly what we wrote here, minus x minus 3. That's allowed. That's what 3 minus x is. Lovely. And then we're going to write the bottom in our factorized form, x minus 3 and 3x plus 4. And now what can we do with this, do you think? Yeah, perfect. We can cancel out the x minus 3. Brilliant. Because they're multiplied, now we're allowed to cancel out. Nothing's, I know stuff is added within the brackets, but the brackets themselves we're allowed to cancel out. And then once we do that, we'll see what it becomes. Well, the top becomes -1, because this is essentially saying that this is -1 times x minus 3. So the top becomes -1, and the bottom just becomes 3x plus 4. And that's as much as we can do for that, but that's a much simpler version. That actually looks quite neat, quite nice. So hopefully that makes sense. A few people want me to go over this again. So I'll do that quickly for you. I'm going to do it by showing you some other examples actually. So if we have, let's say we have 5 minus 2x, and we want to get the 2x there. Well, okay, let's do it with a lot of steps. Hopefully this will make sense. I'm going to first of all swap them around, minus 2x plus 5. That's allowed, right? All I've done is I've just swapped the order. We're allowed to do that. A plus B is the same as B plus A. We're allowed to swap them around. It's just minus 2x plus 5. Then I'm going to take out a factor of -1. Just like sometimes we can take out a factor of 2 or take out a factor of 3. So we're going to take out a factor of -1, which we just write as minus. For now, I'll write it as -1. And then if we take out a factor, we have to know what we're left with. So if we take -1 out of this, we're left with 2x, because 2x times -1 gives us our minus 2x. Basically, if we divide by -1, what are we left with? We're left with a 2x. And if we divide 5 by -1, what are we left with? -5. And then we just write this, because it's just -1, we just write it as minus. You can keep it as -1 if you want to. That's totally fine. And it might then help you when you cancel out. When you cancel this out, it might help you to see that there's a -1 left. So you can do whatever you want. I just write it this way. And then what I did was I just skipped these steps in the middle and went from here to here. And if you don't believe me, you can factorize this one, expand this one out, sorry. And we get minus 2x from here. And then doing these, we get minus 5 minus, oh, I don't know what just happened there. minus 5, which is minus 2x plus 5. And then again, if we just swap that order around, it's 5 minus 2x. So that's kind of proof that it is the same thing. Does that make a bit more sense? I'm gonna leave that there for now so that we don't get too hung up on this, and go over some other questions. Okay, I'm going to do this question here. So, show that questions are lovely. If you see a show that question, you should be very happy, because it means that you can know that you've got the answer right. Yeah, we have to be a tiny, make sure that we're careful that we show our working, because obviously we've kind of been given the answer. But it means that you know when you've reached the right conclusion, which is really cool. So in this question, we want to show that a over b plus 1 minus a over b plus 1 squared can be written as ab over b plus 1 squared. So does anybody have any ideas about how we might go about doing this one? Yeah, cool. Some people have some really good suggestions. Yeah, perfect. So we're going to write them with the same denominator. To subtract fractions, we have to write them with the same denominator. That's how we have to work with fractions. And we can see that the denominator that we can get them both to is b plus 1 squared. And we can do that if we multiply this first fraction, multiply the top and bottom by b plus 1. Because b plus 1 times b plus 1 is b plus 1 squared. So I'm just going to look at this and say that we can write this as a lots of b plus 1 over b plus 1 squared. Hopefully that makes sense. So we've got b plus 1 on the top, b plus 1 on the bottom. I haven't done any expanding, nothing fancy. I've just multiplied the top and the bottom by b plus 1. And now we can rewrite this out. So we've got a lots of b plus 1 over b plus 1 squared minus a over b plus 1 squared. And that means that we just subtract that a from the top. If you remember, that's what we do with fractions. It's no different just because we've got some algebra in there, just because we've got some letters. It's exactly the same thing. So this is going to be a lots of b plus 1 minus a over b plus 1 squared. Because they've got the same denominator, we can kind of smush them together, smush that denominator, and then the top just combines. So we've just done this minus this. Hopefully that makes sense. And then we can see that we're really nearly there. We just need to do some things with the numerator. So this is going to be the same as, well, let's expand out that bracket. That's the same as AB plus A minus A. So that minus A is just tagged onto the end. This, I've done A times B and A times 1 and added them. That's how we expand brackets. And that's all over B plus 1 squared. And then hopefully you can see that we've got a plus a and a minus a. So they're going to cancel out, leaving us with ab over b plus 1 squared. That was a really bad plus 1, wasn't it? Gosh, it looked like an h. B plus 1 squared. And that is exactly what we've been asked to show. So then I always finish these with something like writing as required, just to prove to them that you know you're done now. From which equals that as required. It's also quite fancy as well, isn't it? I don't know, makes me feel smart. Okay, a couple of people asked me to go slower or explain it again. Let me just see if there's a similar question that I could do. Okay, I'm going to do it with a different question, just so that if people have got it, they don't have to hear me droning on again. But for those who don't get it, hopefully you'll understand if I do it with a different question. So this is slightly different, but the same principle is going to follow. So we want to write x over x minus 1 minus x over x plus 1 as a single fraction in a simpler form as we can. So we're going to do the same thing. We want to get the denominators to be the same, because we can't add or subtract fractions until the denominators are the same. So the only denominator that we know is a multiple of both x minus 1 and x plus 1 is going to be just multiplying them together. Because we know that x minus 1 is a factor of this. We know that x plus 1 is a factor of this, so that's what we're going to do. It's like if we had something over 3 and something over 4, we might make it something over 12 by multiplying those things together. So that's what we're going to do. So let's think about it one at a time. Let's take this half first. So we've got x over x minus 1. And we want to write that as something over x minus 1, x plus 1. Because that's what we want our denominator to be. So we take a look here and we think, well, what did we multiply this by to get this? We multiplied it by x plus 1. So that means we have to multiply the top by x plus 1 as well. So that's x, lots of x plus 1. And you see, we haven't changed the fraction at all, because we could cancel these out. It's the same fraction, but we've put it in a form that's going to help us when it comes to subtracting x over x plus 1. If you ever get confused with this, try to imagine it with numbers. Imagine you're doing 4/5 minus 2/3. And you should start to see the similarities between what we're doing. Now let's have a look at the second fraction here. X over x plus 1. Well, we want to write that again as something over x minus 1, x plus 1. Now, what did we multiply this by to get this? We multiplied it by x minus 1. Yeah, we multiplied it by this bracket here. So we're going to do exactly the same to the top. We're going to multiply the top by x minus 1 as well. So hopefully that makes sense as to how we make these share a denominator. And now this means that we're allowed to subtract them, and then we can simplify it down, like the question said, write it in its simplest form. So now we're going to write this blue fraction here, x lots of x plus 1 over x plus 1. Actually, before I do that, I'm just going to, I think, show you. No, well, I'll leave them combined for now, actually, sorry. X minus 1, x plus 1. Minus this green fraction. All I've done here is I've just copied them down with the minus sign in the middle. Just to make this into our question. And now we can smush them together. Because the denominator is the same, we're allowed to smush those two top bits together. So we get x lots of x plus 1 minus x lots of x minus 1. Just going to check the chat to make sure that people are following. Yeah, someone's talking about expanding the denominator. We're going to do that at the end to show that's a really good insight to have. So what we're going to do now is I'm actually going to move it over this way. We're going to forget about the denominator for a moment and work on simplifying the numerator. I'm only doing that so that I don't have to keep writing the denominator every time. So we'll just have a look at this. And what we're going to do is we're going to expand each little mini bracket. So this first one, let's color code it even more. This first one here, we're going to get x squared plus x. And that's because x times x is x squared and x times 1 is x. Again, that's just a rule of expanding. Hopefully you can follow that. Now this bit's quite important because we're multiplying this whole bit by minus x. So we're going to do minus x times x, which is minus x squared. And then minus x times minus 1, which is plus x. I hope that makes sense. Have a look back in your own time and try to follow it if you can't at the moment. So we've done minus x times x and minus x times minus 1. Got to be really sneaky when we're expanding by a negative. And then hopefully you can see here that we've got an x squared and a minus x squared. So this just becomes x plus x, which is 2x. So then if we kind of section that bit off, this whole fraction here, well, we just said that the numerator equals 2x over our denominator. And if we think about what our denominator is, when we expand it out using the FOIL method, we get x squared plus x minus x minus 1, which just equals x squared minus 1. So we get 2x over x squared minus 1. And this is as simple as we can make this. So this is the fraction in its simplest form. This you might have spotted actually was the difference of two squares. That's why the x cancels out. So hopefully that makes sense. You would probably still get the marks if you left it like this, because I guess it's mostly talking about combining and simplifying the numerator. I can't be 100% sure though. Okay, I know there are still some questions, but I only really have 5 minutes of this before questions, so I'm going to try to do another question. I'm going to do this one. So let me just copy the grid first, and then I'll copy over so this is one about shading inequalities this time. And yeah.
Hi Molly, just before you carry on, I know you said we have 5 minutes for questions, but quite a lot of the questions that have come through on the Q&A are around either doing more examples or slowing down and kind of going over what you've said before. So on that note, I think it's probably best if we just carry on doing as many examples as we can.
Oh, okay, sure.
Unless there's anything else specific that comes up, which I'll flag to you when it does.
Okay, sure. I'll do more like this then. Cool.
Great.
Okay, so I'll do another one of these about combining fractions then. I'll just kind of come up with one myself. So we're going to look at combining 3x over x plus 2. I'll do it with plus this time. 4 over x plus 1. And we want to know how to combine those into a single fraction. So can anybody think from the previous methods what we're going to do here? Yeah, exactly. Yeah, brilliant. Everyone's saying make the denominators the same, which is perfect. So yeah, one person said it. What do you think we're going to make the denominator here? What do you think we can make it that's both a multiple of x plus 2 and a multiple of x plus 1? Yeah, brilliant. A lot of people are getting it, which is good. Don't worry if you're not, though. I'll try to explain it quite simply. Okay, so some people are saying just make it x plus 2. Not quite. And the reason is because we want to be able to multiply this by something to get x plus 2, which we can't exactly do. I'll do another example where that's the case. But the correct thing that people were saying was that the denominator is going to be x plus 2, x plus 1. When in doubt, just multiply the denominators together. It's what we do with just fractions without the algebra. If you were adding 1/3 and 1/2, you would make it something over 6, right? Because 6 is 3 times 2. Hopefully that makes sense as to why we're going to do this. Does that make sense for those who thought it was x plus 2? Does it make sense why we can't do that? Okay, good. Oh, someone said no. I'll try to explain it as I'm doing it in the question. So the reason is because we want to write both of these over the same thing. And we can only edit these fractions if we times the top and the bottom by the same thing. We can't times x by 1 by anything to get x plus 2. We can add 1, but we're not allowed to add 1 to the top and bottom of this fraction. That's not one of the things that we're allowed. We're only allowed to either multiply or divide the top and the bottom by something. So we're going to do this method, and we're going to look at these fractions one at a time. So let's first of all have a look at this first one. Well, we want to write it as something over x plus 2, x plus 1. So what if we multiplied, we need to think about what if we multiplied the bottom by to get to here? Well, we've multiplied it by x plus 1, right? We've multiplied the whole of the bottom by x plus 1. We've just got to think about x plus 1 as an entity in its own right, just a thing, x plus 1. And therefore, we must times the top by x plus 1 as well. So that our top is 3x, and we've got to also times that by x plus 1. Hopefully that makes sense. If you want, at the same time, I hope that this doesn't confuse people more. I'll try to do a parallel with normal fractions at the same time. So let's say we had 2/3 plus 4/5, because hopefully this is one you're comfortable with, and if you can see the links between them. So what we've decided here, in exactly the same way, is that our denominator is going to be 3 times 5, which is 15. Right? We've decided that our denominator, and that's just like here, we've decided that our denominator is going to be these multiplied. And then what we've done is we've had a look at this first one, 2/3, and we've said, okay, to make the bottom 15, or 3 times 5, what have we multiplied 3 by? We've multiplied it by 5. So we have to do the top one times 5 as well. Hopefully you can see how this and this, I know they obviously don't look the same, but hopefully you can see how they are the same thing. This one is just with x's instead of straight up numbers. Okay, cool. I think this is hopefully helping make a bit more sense, doing it with the numbers at the same time, which is good. I didn't want to confuse you more. Okay, now we'll do this side as well. Let's see what this becomes. We also want to write this as something over x plus 2, x plus 1. And now we're going to do the same thing, and we're going to think, what have we multiplied x plus 1 by to get to here? We've multiplied it by x plus 2. That whole entity in its own right, x plus 2. Just think about it as a one thing. So we have to multiply the top, which is 4. We have to multiply that by x plus 2 as well. And that's the same if we go to our number example here, as saying, well, we want to put this as 15, 3 over 5. What have we multiplied 5 by to get 3 times 5? Well, we've multiplied it by 3. Therefore, we have to multiply our numerator 4 also by 3. And hopefully, drawing those parallels, you can see why we're doing it this way. I think everything always looks a lot more confusing when you throw terms with x in there, but it's really not. I mean, obviously it's harder. But if you ever get stuck, just think about, what would I do if these were just numbers? What would I do if there were no x's? And do exactly the same process, just with horrible letters in there. And now what we're going to do is we're going to smush these together. We're going to combine them. So what I'm going to do first of all is just write on my example over here. I'm just going to actually multiply these numbers together to show you. So 10 over 15 and 12 over 15. Hopefully you can see that this is the process that we would always do. I know you would never write it like this, but that's to show you what we're doing here. Because obviously we don't know how these combine when we multiply them yet. And now, if we had this one, we just write them both over 15, right? And you just add the tops. So we would have no problem in writing this as 22 over 15. I'm actually going to write it as 10 plus 12 over 15, just to do it in even fewer steps, really breaking it down. And that's exactly what we're going to do here. We're going to write it as one thing over x plus 2, x plus 1. And that one thing is just going to be 3x lots of x plus 1 plus 4 lots of x plus 2. All I've done is I've just, as I keep saying, I've just smushed them together. Just added those numerators together exactly like I did over here. There's no difference at all. 10 plus 12, 3x, x plus 1 plus 4x plus 2. I know they obviously sound very different, but it's exactly the same idea behind it. And then finally, we just want to expand and simplify this top bit. So in this case, I'm going to go off and do it separately so that we don't have to keep writing out the denominator, sorry. So here, I'm going to go off and go, well, 10 plus 12, that's equal to 22. So I'll write that over my denominator, and that's how we've done that one. Exactly the same over here. I'm going to take away my numerator, and I'm going to work out how to simplify it. Well, I can simplify it by expanding out each section. So 3x lots of x plus 1 is 3x squared plus 3x. Hopefully you can see how I got that. That's just expanding out this bracket. 3x squared plus 3x. And then this second bit here, 4 lots of x plus 2, that's going to be 4x plus 8. Hopefully you can see how I got that one there. And then let's simplify this for ourselves. Well, we've only got one x squared term, but we've got two x terms. 3x plus 4x is 7x. And then we add 8. And then we just do exactly what we did over here, and we write that numerator that we've worked out over our denominator. 3x squared plus 7x plus 8 over. Now you can either expand out the bottom or you can leave it as it is. They're both just as complicated as each other, so I'm going to choose to leave mine as it is. But you can do either. They're both answers to the question. The examiner won't mind which one you do. So there you go. Did that make a bit more sense? Yeah, cool. Awesome. Someone's asked to do a quadratic inequality exam question. Does anybody else want to do that, or does anybody have any other things? Now someone said, can you please speed up? Oh gosh, it's so hard. Okay, yeah, okay, a few people want to do quadratic inequalities. I think that was probably one of the hardest things we did this week, so let's go over one of those. Cool. Let me just see if there's any on these question papers. I'm not sure if there will be. I might just have to come up with one. So let's come up with one. Let's say solve. Okay, just give me a second to think about it.
While Molly is just looking for the question, if you do have any more questions, then we've still got 10 minutes, so make sure that you get them through to us before the end.
So I'm going to do x squared minus 8x is less than minus 12. Okay, sorry, it's quite hard to come up with the questions. So this should work though. This should do what I want it to do. So let's start off by making sure that we understand the question itself. So basically, we're just looking for something that when we square it and subtract 8 lots of it, it's less than minus 12. That's what this means. That's what we're looking for. So what we're going to do is, just like if this was an equal sign, we want the right-hand side to be 0. And that's because when we have a quadratic, we can work with it better when we have something being equal to 0. So all we're going to do is carry this 12 to the other side. With an inequality, we're allowed to do that. So we're going to add 12 to both sides. So we've got now an inequality, a quadratic that we're familiar with, and 0 on the other side. Only difference is that here we've got a less than instead of an equal sign, which we're not quite familiar with yet, like as comfortable as equality, but it's no scarier. So what we're going to do now is our favourite thing to do with quadratics. We're going to factorise it. So hopefully, I don't know, people have started having a go at it. Yeah, people are getting this right, saying bring the minus 12 to the side and factorise. So what do you get, do you think, if you factorise this one? I'll just give it like 30 seconds and then go through it. Yeah, perfect. Okay, brilliant. People have... Okay, interesting. Everybody's got the numbers right. Some people have got the signs slightly wrong. So, okay, yeah. So I'll briefly explain how you do this, just because factorising is always quite difficult. So all I'm doing now is, this is just the setup. This is what it's going to look like. We're going to put x's in here because it's just an x squared. We know that. And the next thing that I always do is look for the signs rather than the numbers first. So this is added, which means the signs have to be the same. It's either going to be plus plus or minus minus, because that's the only way that we can make a positive 12, is by multiplying 2 positives or multiplying 2 negatives. And they're going to have to be, they have to add up to minus 8. So they've got to be negatives. There's no way that 2 positives are going to add up to minus 8. So these both have to be negatives. And then everybody got the numbers right. So we want numbers that multiply to make 12 and add to make 8. And it's going to be 2 and 6. So well done. A lot of you got that, or people who got it wrong, you still got the numbers right, which is really great. Okay, so we haven't done much special so far. We've just rearranged and factorised. What we're going to do now is find what are called the critical values, which I was speaking about yesterday. And these are the values where we pretend that this is an equals. So the values where this equals 0. So hopefully from last week's factorisation, you'll remember that that's when either one of these brackets is equal to 0, and that occurs when x equals 2 or x equals 6. So what we're going to do is sketch this curve. And what these points tell us are where it crosses the x-axis, because that's where it's equal to 0. And when it's equal to 0, that's what y is. Let me try to explain that. If you don't understand the reasoning, just kind of know how to do it. So here's a graph. I'm going to pop on the points 2 and 6 here. And because the curve that we're going to draw is y equals this lovely quadratic, the points where this equals 0 are the points where y equals 0. That's what this means. When this is 0, this is 0. That's what an equation is. And this whole line is y equals 0. So it occurs when x is 2 and when x is 6. They're called the roots of the equation, and they lie on the x-axis. And then we can draw the curve. It's a positive x squared, so it's going to be a smiley face. And we know it has to go through these points. So we know that it's going to have to look something a little bit like this. So hopefully everybody's with me so far in how we sketch the curve. Yeah, some people have already got the inequality, which is great. So now, nothing that we've done so far. I know that the sketching the graph is quite hard, but we haven't actually used the inequality yet. So here's where we're going to use it. We want the point where this curve is less than 0. And we've got to remember that this 0 is the y, which I said was this line. Now, what values of x are less than 0 on that curve? What do you think? Some people have looked as good. Yeah, perfect. Someone's given a really good answer, which is 3, 4, and 5. So not 2 and 6. So if we're just thinking about whole numbers, exactly. If we put some points on here, if we think about 3, yeah, that does give us a value less than 0. If we think about 4, yeah. And 5, yeah. If we were to try the value of -1, no, that's going to hit the curve way up here, which is definitely more than 0. So hopefully we can see that we're trying to find this bit of the curve. It's everything less than 0. So it's underneath less than 0. So that's this bit of the curve. Well, this bit of the curve falls between 2 and 6. So that's all we're going to write. Our solution is going to be that x is between 2 and 6. So it's bigger than 2, but it's smaller than 6. And the reasons that it's not 2 and 6 is because this is a strict inequality. Because at 2, it equals 0, which is not less than 0. So basically, whatever sign is here goes here. So whether it's a less than or less than equal to, that makes the difference. So this is our solution. This is what we've solved. Does that make a bit more sense? Does it? Oh, awesome. People saying that it makes a bit more sense. Yeah, someone said x greater than 2x less than 6. Perfect. So hopefully this is making a bit more sense. I know we're pretty much out of time, but are there any short questions, Frederica?
Cool. Well, there isn't anything that I think we'll be able to cover in this session, but for the people who might have found it a little bit tricky and weren't sure what was going on, this was the summary session going over everything that was covered this week. So we've kind of built up from having much easier session at the start of the week to where we are now. So don't worry, you can find all of those videos of the recordings of the sessions and watch them back if you want to, and that will probably help you catch up to where we are today, and then hopefully when you watch back today's session it will all make a lot more sense. So yeah, just to say that they're all recorded, so don't worry if you couldn't always follow everything at once. To get the recordings, make sure that you have signed up to the My Tutor online school, and if you go onto that page then you'll be able to find all of the links to the recordings. So the only final thing to say is there'll be more math sessions next week, and stick around for physics at 2 o'clock today. So yeah, thanks guys, thanks for joining us again, and thank you Molly, and hopefully see you guys in more sessions shortly. Bye.
Thank you everybody.